The value of standard reduction potential and standard cell potential can be calculated by using the formula that we have seen in here. E naught cell equals to E naught cathode minus E naught anodes. Therefore, by using this equation, we should be able to find out the cell potential at standard conditions. So standard cell potential, as you can see over here, so this is the one that we have in there. So when you have standard cell potential, when you see this, then you should be able to understand that that symbol over there signifies standard, and that signifies cell, and that should be the potential. So whenever you see this symbol, when you have your potential, cell, and naught right there, this is the standard cell potential, the formula that we can use, or the equation that we can use to calculate the cell potential at standard conditions. Standard condition usually refers to the concentration at 1 molar, the pressure at 1 atmospheric pressure, and the temperature at 25 degrees Celsius, okay? But usually we're going to focus on more on the concentration of the electrolytes and the pressure of the gas when we refer to the standard conditions. What happens if we have a non-standard condition? So what sort of equation that we need to use? So for non-standard conditions, we're going to use the cell potential. Note that over here, you do not have the symbol naught. So when you do this, when you use this, this is when we want to calculate the cell potential that is not at standard conditions. And the equation that we have here is the Nernst equation, which enable us to calculate the cell potential under non-standard conditions. So you have E cell, which is the cell potential, equals to the standard cell potential minus with R. R is the constant right there, 8.314 joule per Kelvin per mole, times by T, the temperature. So you have to take into account the temperature, and you need to change that temperature into Kelvin, divide by N, and over here is the number of mole of electrons involved in the galvanic cell, or the number of electrons passing through in the galvanic cell. And then times with F. F is another constant, which is the Faraday constant, with the value of 96500 coulomb, times with ln. So we're going to use ln instead of log, times with the concentration or the pressure of products to the power of X over the concentration or pressure of the reactants to the power of Y. So when you want to write the Nernst equation in exams, you have to write this whole thing over here together with the definitions or the descriptions of all of the things that you need to have in the equation. So I'm going to repeat that. So you have to write this if they want you to write the Nernst equation, and also you have to include that one when you want to write the Nernst equation. Now, we can simplify the Nernst equation if you have the temperature 298 Kelvin and the Faraday constant is equals to 1. Okay, so when you have this kind of situation, you can simplify the equation to become like this. Okay, so that is how you can simplify that one, and that is only for temperature equals to 25 degrees Celsius. So if you have a different temperature than 25 degrees Celsius and the constant over here is not 1F, but usually it's going to be at 1 Faraday, then if you do not have the temperature at 25, so you have to use this formula over here. But if you have the temperature at 25 degrees Celsius, you can use the simplified version. If you want to use log instead, so you do not want to use ln, you want to use log. So you can use this. Okay, you're going to change your change ln into that, okay, 2.303 times log. So you have to be careful, okay, if you want to use the real Nernst equation right there, you always remember to use ln instead of log. But if you prefer to use log instead, you need to remember that ln is equals to 2.303 log. Let me write that down there. So you need to remember that ln is equals to 2.303 log. So you have to remember that. Therefore, I would highly suggest for you to try to memorize this for, the simplified Nernst equation for the temperature 25 degrees Celsius, and remember the real Nernst equation, the full Nernst equation, so that when the question gives you different temperature, you would be able to answer that question correctly.